So today's lecture topic is decision tree. Okay, this is a classification algorithm, and myself, Dr. Dibya, presenting you the lecture series on machine learning. So let's start today's class. A decision tree is a structure that includes a root node, branches, and leaf nodes. Okay, so these are the main parts of a decision tree. That is, we should have a root node, some branches, and leaf nodes. And leaf node, from that node means no child is going to be generated. So each internet node denotes a test on an attribute. You have to note it down. Every internal node represents a test on an attribute. Then each branch denotes the outcome of a test, and each leaf node holds a class level. Okay, so internal node representing a test, branch denoting the outcome of a test, and the leaf node holds a class level. And the topmost node in the tree is no doubt your root node. Let's have an example on this decision tree. So this decision tree that we are going to learn is for the concept by computer that indicates whether a customer at a company is likely to buy a computer or not. So look at this picture very carefully. You can take a screenshot of this also. Say S, then from S we have branches 3 edges coming out of this S. Then of course this S is the root node. Then we have young, middle-aged, and senior. These are the edges coming out of S. Then if it is young, then whether student or not. The internal node, just I explained you that internal node denotes a test and the branch denotes the outcome of a test. So you see, this is the internal node. It's a test whether he is or she is a student or not. And branch, the outcome, isn't it? Means outcome of the test. So see, of this test means whether he is or she is student or not. So that is being the outcome through these edges or branches. So no or yes. So and lastly, we have the leaf nodes as no or yes as their class levels, isn't it? So that's an example from one side. If age is young, if he is student, then yes, the probability is of buying the computer is yes. If he is not a student, then of course the probability is no if he falls under the young age. Then if age is middle age, then we have the class level or as the leaf node, yes. Then if he is senior, then we have one more testing that is credit rating. If credit rating is fair, then he's not going to buy the computer because we are talking about fair. And if credit rating is excellent, then he or she is going to buy the computer if he falls under the senior age category. So you have seen how we are actually performing the classification through this decision tree. You should note it down every step. You should try to explain each branch out of it. That's your homework. Do it. Okay. What are the benefits of having a decision tree? Benefits are it does not require any domain knowledge. Second benefit is, of course, it is easy to comprehend. Then third one is that learning and classification steps of a decision tree are simple and fast. So these three benefits a typical decision tree possess. Okay. Then I hope this lecture is means you are able to get what is decision tree, how to construct one decision tree from the given data set. Okay, so I talk about the basic algorithm. If someone asks you what is the basic algorithm for decision tree inductions, then I'm going to give one such algorithm for you. And this basic algorithm is a greedy algorithm. So steps are Tree is constructed in a top-down recursive divide and conquer manner. These terms are very important. Top-down, as you are moving down from the root. Okay, trying to build some leaf nodes, trying to build some leaf nodes through the means continuous succeeding the branches, the test portions in the internal node, you will finally come to a leaf node from the root. That's why this is a top-down and recursive divide and conquer, because we try to divide and then conquer. So this basic algorithm for decision tree is a kind of top-down recursive divide and conquer type. Okay, you should note it down. So at start, all the training examples are at the root. Then attributes are categorical. Okay, attributes, we have categorical attributes. If continuous values, they should be discretized in advance. So you are going to tell me, what do you understand by categorical attribute or categorical variable, and what is continuous valued attribute? Okay, do comment the answer. Then examples are partitioned recursively based on the selected attributes. Then test attributes are selected on the basis of a heuristic or statistical measure. As for example, you can consider either information gain or several other things are also there. Then when you will stop partitioning, means there should be some condition for that. The conditions are all samples for a given node belong to the same class, or there are no remaining attributes for further partitioning, and majority voting is employed for classifying the leaf, or there are no samples left. So these are the conditions on the basis of which you will stop partitioning. That's all for today's class. And one important question for you. You'll tell me through comment, what are the characteristics of ID tree, C4.5 and CART decision tree algorithms? What are the characteristics of ID tree, C4.5 and CART algorithms? You are going to answer this question through comments. So guys, that's all for today. Enjoy the lecture. Okay, take care. Bye bye.